So these are both electrolytes, they're both water soluble, so far so good. In calcium chloride, our cation is Cl+, our anion is Cl-. We just have two of them there to balance out the calcium, but for this purpose here, we just want to know what type of anion we have. We're not trying to make weird polyatomic structures here, and we're also not trying to balance the equation yet either. Same way here with our lithium phosphate, our cation here is simply Li+. We're not going to worry about the fact there's three of them yet, we'll worry about that later when we balance the equation. And our anion here is phosphate. When we swap partners, the Li+ and the Cl- will now be paired together, and the calcium 2+ and the phosphate will go together. Now, by the way, if you put the calcium and the phosphate here and the lithium and the chloride here, it's exactly the same. Just like 1 + 2 is the same as 2 + 1. Doesn't matter what order you have them in. Now that we have our new pairings, let's make some valid chemical formulas. Li+ and Cl- go together 1 to 1. And that's a reasonable formula then for lithium chloride. Once again, that least common multiple of 6 pops up here. We're going to need 3 calciums to balance out 2 phosphates. And so this would be the formula of our second product, calcium phosphate. There's our products, and now and only now we can balance the chemical equation. You can certainly balance with tallies the way I've been showing you, but ultimately as you get more advanced in chemistry, you should be able to balance an equation just by eyeballing it. So you can still use tallies if you're more comfortable that way, but try to advance to a point where you can just eyeball an equation and balance it like that. Notice I need 2 phosphates over there in my product. That'll require 2 lithium phosphates. I now have 6 lithiums, so I'll need 6 chlorines to balance that out, and we're done. And after all that, will this reaction actually work? Is lithium chloride water soluble? Yes, it is. Lithium is a group 1 cation, so it's definitely water soluble. What about calcium phosphate? No, like most phosphates, it is not soluble. So it'll be a solid precipitate here. Calcium phosphate, by the way, is the major ingredient in bones. So it's a good thing calcium phosphate isn't water soluble. If it was, we'd all be like jellyfish oozing around on the floor. The fact that our bones are insoluble in water makes them not dissolve in our bodies, and that's good.
You said we don't have to memorize this table. You'd give us one on the quiz?
Would you like to memorize it?
No.
Yeah, I'll give it to you on the quiz. Sure. So we're building up a big packet here. We got the periodic table, the solubility table, and we'll get other stuff as time goes on too. You don't have to memorize it. You guys ready for another one? Excellent. Good. Well, you can see that chemistry spirit. Let's try this one. Cycle our iron 3 sulfate here.